Okay, this is going to be a video on doing symbolic computation in MATLAB, so let's jump right in. For MATLAB, you have to define functions and symbols in such a way that it understands what it is you're actually doing. So I'm going to define a function like this. Two pieces. First, you have to define the symbolic variable. And then you have to define the function. You're doing this because this notation here could mean look at the thing f and find the x entry in that, or it could be look at the function f and use that as the independent variable. That's what we actually mean here. And so defining it as a symbolic first tells MATLAB, hey, we're about to actually use this thing just like you would write functions down on paper. So let's just do something simple like plot this thing. Let's see what this function looks like. And we'll do it on kind of a simple domain, minus pi to pi. And Control Enter runs it, and here we go. We got a nice little plot. Let's turn the grid on. And notice that it's echoing this back to me on the command line, so if I didn't want to see it, I can always use the semicolon to suppress it. Control Enter runs the whole thing. So this is a fairly easy, straightforward thing to do. So now let's just evaluate this function. In other words, like if I wanted to do f of 2, naturally I would just type f of 2, and it tells me what that is, or f of 0, and it tells me what that is. Now, notice a couple of things. First of all, with f of 2, I didn't actually tell it what to name this thing, so let's call it like my value at 2 equals. Okay, so now I actually have a variable name for it, but notice that it also gives me something that's kind of nonsense. 2 times cosine of 2 is kind of hard to read. So if I use the double command, double does not multiply it by 2. It actually changes it to a decimal. And now I've got something that's easy to read. So I evaluate the function at 2, and then actually get it to human readable form. And of course you can do this with other things too. F of 0 is 0, so it's actually really easily readable. F of 1 is cosine of 1. Hard to read, so if I just use the double command I can see it. And of course on the plot I can verify, yep, that looks like it's about 0.5. And in the plot window, if I click on the little data cursor and then come down here and oops, let's try that again. Click on the data cursor. Pretty close to 1, it's about 0.55. So we can see that pretty easily. Okay, so now let's do some symbolic calculus. Say we wanted to do a limit. A limit, you would read it as limit of the function as the variable goes to, and let's just say, let's take f of x as x goes to 1. Right? That's how we would read the limit notation you see on paper. Well, MATLAB is nice enough that we're actually going to type exactly those things. Limit of that function as that variable goes to that number. Run it. It tells me what it is. Let's call that thing L just for simplicity. You can use the double command to get it back into decimal form, and all is well. It'll also do derivatives. So if I just use the diff command, so I'm going to tell it what function to differentiate and what variable to use. But notice, of course, the derivative is actually just a function, so let's just call it a function. df is just the name that I'm using for the function. And I run it, and now I've got a new function named df, which I can evaluate at places if I wanted to. There it is. I could do all sorts of things to it. I could hold the plot on and then plot that guy. And now I've got a plot of my derivative along with my original function, which is pretty cool. There's all sorts of other things you can do with the symbolic toolbox, but I think I'll stop there for now. This gives you the basics of some symbolic calculus, symbolic plotting, and function evaluation.